Here we are at the very last bit of our theory for acids and bases. So we've looked at our definitions, what they are, conjugate acid-base pairs. By now you should also be able to use your pH equations, understand the pH scale, and also be able to apply that to uses in volumetric analysis. So now we're going to look at the applications in the wider scope of chemistry. And in this case, we're going to look largely at the application of acid-base chemistry in the environment. And this is pretty critical, particularly with a growing industrialized civilization. We have a situation where we're producing lots of pollutants, and these pollutants usually end up being acids in our environment due to the nature of the acidic oxides that they form. So essentially, we need to know the contributors to acid rain, the definition for acid rain according to what the IB defines it as for us to be able to answer exam questions, and some of its impacts. So largely, when we're talking about acid rain, we're talking here about rain that has a pH lower than 5.6, and this is due to the contributions of sulfuric acid and nitric acid, which come about from pollutants that are released on the burning of petrol and or coal. So nitrogen and oxygen gas combine at high temperatures in combustion engines. So this is pretty much in all engines except your electric hybrids. But what happens is nitrogen fixation, where we take elemental nitrogen into other forms, doesn't typically happen. It's quite hard to make happen unless you've got nitrogen fixing bacteria in our soils and things like that. But it can occur in high temperatures. So where we have a combustion engine, the air that provides the oxygen for our combustion engine also contains nitrogen. So when that fuel explodes inside the pistons that power our cars, it will combine with oxygen in this first equation here. And then that can combine with a further equivalent of oxygen to give us 2NO2 gas. This is put into our environment and gives some of the brown color that we see with smog. Now, if it rains or as it goes up into the upper atmosphere, it can react with water in our atmosphere, and it turns into HNO2, nitrous acid, and H plus and NO3. So we can get HNO3 as well. So you actually need to know these equations. So I recommend putting them on a flashcard and learning them, and learning where the sources of this nitrogen oxides gases come from. It can occur naturally around volcanoes and lightning, but that's generally in low amounts that it doesn't really contribute to what we know as acid deposition. Sulfur, our main source of sulfur is also from fossil fuels, and this can come from coal. Generally, coal has a larger amount of sulfur, particularly brown coal. This means that when sulfur and high temperatures again reacts with oxygen, we get SO2. SO2 reacts with the further equivalent of O2, and we get 2SO3, which will then react with H2O to give us sulfuric acid. This has quite significant effects in our environment in terms of damage to our buildings, which we see in this one here, and can also change the pH of our waterways, making them unsuitable for the sustainability of plant and animal life in our waterways, which affects our general well-being and the health of the environment with which we live. So this just gives a quick rundown of the source of what we refer to as NOx and SOx. When we say NOx and SOx, we're talking about this X here, which is just saying that it's a variable number. It can be NO, NO2, NO3, or it can be SO2 or SO3. So it's just saying that we have variable numbers of oxygen combining with our nitrogen or sulfur to form these gases. Primarily, we're talking about utilities such as energy production and otherwise. You'll notice here that with NOx, one of the largest contributors is transport, and that's because of the nitrogen fixation in the high temperature combustion engines. And then we've got industry and manufacture and other combustion, but primarily it's our electricity production for SO2 and SO3 because of the burning of coal, and for NOx and SOx, for NOx in particular, it's transport due to the fixation of nitrogen in the combustion engines. So what the IB refers to this as is acid deposition, so where we get acid rain, or it can be dry deposition as well, which we tend to see happening around the sides of roadways and things like that. So acid deposition by definition is the process by which acid particles, gases, dry deposition, and precipitation, wet deposition, leave the atmosphere. Okay, so this is our definition. Essentially what that means is it's any form of precipitation can be contaminated with different acids. Importantly, when we answer questions on this, normal wet deposition, i.e. rain, okay, has a pH of around 5.6, and this is because of the natural levels of CO2 in our environment. Okay, we have CO2 in our atmosphere. It is a natural part of our atmosphere. We would not have the warm climate that we do without it. The enhanced levels of CO2 in our atmosphere that we relate to global warming are additional to this normal amount of CO2. But because CO2 is normally in our atmosphere, it reacts with water to form carbonic acid in a natural process that gives rainwater a pH of around 5.6. Anything less than 5.6, i.e. contributors due to nitric acid and sulfuric acid due to pollution from SOx and NOx, is considered acid deposition. Okay, so if it's 5.6, then it's not acid deposition according to what we're going to answer in our exams. This is the sources of acid deposition, which we've largely already given off, okay, and talked about. Industrial power plants are the main contributors in industry, and as we have growing industry around the world, that becomes a more considerable contributor. And then we have natural sources of this as well, such as volcanoes, plankton and their biological processes, rotting vegetation, and things like that. Okay, and this here, so this is our thiol here. This will be rotting vegetation giving rise to SO2 and H2O. Okay, so this is natural and man-made sources. These reactions then, okay, so if we have SO2 gas being produced from coal burning, okay, this reacts with moisture to form sulfuric acid, and then our NO and NO2 from car exhaust reacting in 3 stages to form nitric acid, or this one here. So make sure you learn these equations. We have direct effects and indirect effects of the acid deposition. Okay, direct effects are clearly things like deterioration of marble structures and limestone structures and things like that, where the acid etches away the limestone, which is this equation here. And you will notice it is a metal carbonate plus acid giving a salt plus water and CO2. A lowering of the pH of the waterways, which can lead to acid shock and damage to surface tree leaves and needles, which we'll talk about a little bit more. But essentially, most aquatic organisms have a very narrow pH, like all living things, under which they are viable. As the pH lowers, then we see damage to those ecosystems. Indirect effects arise from leaching of nutrients from the soil. Now, you don't need to know this in huge detail. There used to be a large amount, and if you look at older exam questions, you'll see that there are 8-mark questions asking about the process of which the proton gradients change and the influence of magnesium, calcium, and potassium on root systems of plants. You don't need to know it in that much detail anymore. What you do need to know is that the effect of acid rain, okay, so hydrogen replaces things such as calcium, magnesium, and potassium ions in the soil, which leaches or removes these nutrients away from the root systems. What it does is that these are now no longer available to be used by the plants, and they get leached into our water supply and cause a nutrient deficiency in the plant life. This table summarizes all those effects for you and the relevant equations here, okay? And this is essentially what you need to know. So you should make some small brief notes about these. You can get explain questions in relations to these, and particularly nature of science style questions in your exams can come from this kind of environmental impact study. This is just a quick one on ways in which we can control it. So there are a number of ways in which industry in particular move to control the formation of these gases, especially since with environmental protection agencies having large fines associated with these now. Smelting, so producing metals from ores. What we can use is we can use limestone to convert SO2 into calcium sulfite, which is then removed as like this sludge from the process. Okay, so this is in the smelting of iron ores and other ores that may contain sulfur, like mercury and things like that. Any SO2 can then be removed by scrubbing, and this is essentially washing the ore or washing the coal, and or just removal from the process. A lot of excess SO2 is now used these days in the production of sulfuric acid for industry, which makes really good use of a waste byproduct into a major industrial chemical. So this is actually a very positive influence on our processes. And as I said, we can remove coal by sulfur from coal by washing it, and then this reduces the amount of SO2. Limestone, okay, reduces SO2 like smelting. It produces a sludge naturally, counteracting those effects. And then lime-based fertilizers are often also used to add to farmland and water supplies where we don't have natural limestone in order to increase or buffer the pH in our waterways. Okay, so these are the main ways that we can look at controlling it. I do know that this one in particular, the washing coal before burning, has come up in a previous exam paper in the last couple of years. And one also where it asks about phosphoric acid. And you'll notice that we haven't mentioned phosphoric acid because there's not a large amount of phosphorus and phosphate that gets converted into phosphoric acid. So it's not a problem, not because it's not a strong acid or it doesn't get converted, but just because there's a small percentage of it in things that cause pollution in our society. So that's it, and that is the very last of the theory for acids and bases. Now it's just a matter of practicing, getting all your questions, and making sure that you are checking in with your teacher if you've got any questions or anything that is still causing you troubles.